Thank you very much. Mark, as always, is very nice to me. I hope you guys can see my screen. You should be seeing a Sherlock screen. So, hello everyone. My name is Gil. I am the Senior Applications Engineer at DFR Solutions. I basically do most of the Sherlock training and a lot of our customer support, especially while you're going through this trial. Most of you will be contacting me at some point, I'm sure, to take a look at your specific problems. Today, don't forget that this is being recorded. So today I'm going to, anything that I do today, you will have it available to you if you just email me or Tom or Mark and ask for it. What we're going to do today is I'm going to go over the basic things in Sherlock. So this is basically what you do when you open Sherlock for the first time ever. I'll go over the installation as well, and then I will show you Sherlock. I will do a survey of what Sherlock looks like, and then we'll go through a project together, the whole process of a project together. If at any time you have questions, you can just go ahead and punch them into the question box. If you'd rather ask me a question through your microphone, raise your hand and let me know, and then I will unmute you and then let you speak. So let me first start with the first thing, which is how to download the software. Tom will send you a link to a license. You will download the license, and then you will go to the following website. You will go to update.dfrsolutions.com. You will choose that license file, and you will download that file directly into the website here, and you will click Download Installer. The Download Installer will pop up a Sherlock executable. So that's the first thing you do, and then you go to java.com. You will click on the internet, which is slow. You will click on this button right here, the download button. You will go down to see all Java downloads, and then you will click on this button. It will download an installer right here, which I will cancel. So what you're going to do is you're going to run the Java installer. You're going to run afterwards. You're going to run the Sherlock installer, and then you should be okay. Let's get rid of that. Once you installed everything, you would be able to go to the Start button, and you would have a Sherlock, or under DFR Solutions, you would have a Sherlock running here. Once you open Sherlock, you will see this window, and you'll know that everything is kind of turned on. Sherlock looks like kind of any other software you've seen, where there's a main viewer, things pop up here. This is where most of the things happen. There's a few more pop-up windows that I'll show you throughout the session. In the left side, we have the project manager. Obviously, when you open it up for the first time, you will not see so many projects. You will just see, it should just be blank. And as you keep working, obviously I have way too many projects. As you start working on project, you will have more of these lines in here. And then we have a bunch of drop-down menus. That's kind of where you interact with the software. The first thing I'm going to do is I'm going to go over the drop-down menus. And then afterwards, we'll do a project, so I'll work more here on the left side. So here on the top, the drop-down menus are split into two parts. There's the project drop-down menus, which is the project CCA, file, parts, analysis, and results. And there are general Sherlock drop-down menus, which are the tools, settings, admin, and help. So in order to kind of explain how Sherlock is organized by project. A project will have a circuit card into it. How many circuit cards you want to put into a project is up to you. You can have as many as you want. You can have 5, 10, 15, however many. Each circuit card is built out of files. So files are kind of like all the raw data that you would like to put into the circuit card. And then we process that, like the pick and place and the bomb, we process it into parts and parts list, and then you run an analysis, you view the result. So let's take a look at the project menu. In the project menu, we have an Add Project button. This is kind of the file start new or like add a blank project. This will basically create a project that is blank. It has nothing in it. You can import a project, which is kind of like a open a saved project that you've created previously in Sherlock. You can also do all of these imports here, various types of imports, ODB Archive, XML Archive, GenCAD, whatever. What this basically does is it does add a blank project plus create a circuit card plus import all of the files that you found in the ODB or whatever archive and create the board for me as well. So this is kind of like a 3 steps in one shot kind of thing. So and that's kind of how you start a project. Once you have a project, you can change the project properties. I'll show you kind of how we do that and what that does. You can delete a project, self-explanatory. Open and close a project, I'll show you in a second. And export a project is kind of like file, save as, and you can export the project as many times as you want. And remember how I said there's a project and then there's a bunch of circuit cards, and the circuit cards have files and parts and so on. So this is also where you can add another blank circuit card or import a previously saved circuit card. So you can have 2 people working on different parts of the circuit, or like version 1, version 2, version 3 of the same board, or the analog and the digital board in 2 different environments, 2 different locations, wherever. You can just export a circuit card and then import it into someone else's project. And then you can also clear project results, which I never use this button. This button is very, very dangerous. And exit, obviously, close Sherlock. So that's kind of the project menu. And remember, the project menu, under the project, there can be as many circuit cards as you want. So here's the circuit card menu. We have a circuit card properties, a bunch of things that you can export from the circuit card. I'll go over the circuit card properties a little bit later. There's a bunch of things that you can export from the circuit card, and then you can delete the circuit card, which is pretty much like delete the circuit card. You cannot undo this delete, so once you delete it, it's kind of like here be dragons. When you click this button, it's gone and you can't recover it. And then you can add files to the circuit card. You can either add files a la carte, one by one, or you can add a bunch of files from an archive. So these are the kind of archives that we support right now, and if there's any kind of archive that you want, just let me know and I'll add support to it. And then also clear circuit card results, which I never use, but save circuit card results, which I use a lot. So, so there's a project, there's my circuit card, a bunch of circuit cards, and if you think about a board is basically made out of 2 things. There's the board, and then there's the parts connected to the board. So the board has a bunch of files that come in, like the layout, Gerbers, ODBs, whatever, and then pick and place in all of these. Go for the parts, right? We don't really do anything with the files other than process them in order to get the data out of them. So there's no editing of layout. There's no editing of drill holes or anything like that. It comes in from the ECAD data in directly as a file, and we never edit the original data. So whatever you had will always remain pristine inside of Sherlock, and then Sherlock will process it into inputs, and on those inputs, then you can process anything you want. There you can change whatever you want. But you will never harm the raw data inside of Sherlock. It'll keep it, but won't harm it. So when you bring in files, there's only 3 things you can do with a file in Sherlock. You can view the raw data that is in the file, view file. You can change the way that Sherlock looks at a specific file and processes the information, which is edit properties. And I'll show you how that works when we actually do a project. And you can delete a file, obviously. You can also show the file location. It'll just open a browser, a regular Windows browser, with wherever you're working off of the project. Don't really worry about that one right now. You'll see how it works. It's kind of self-explanatory once you see it. If, for whatever reason, you processed a file and it has other options for that specific file, like once you process a file and it becomes a layer, you will have another pop-up here that will give you the ability to view the layer, which basically means Sherlock is telling you, I've processed the information in this file, and it is now available for you to view as a layer. And I'll show you how that works a little bit later. The parts menu is, so you know, the files that create the layout and the board outline and all of those go into the files. The parts is where you do two things. Number one, this is where you interact with your general parts library in your AVL down here. And this is also where you interact with your parts list. So the list of parts that are sitting on the board, you can import a parts list from outside. So if you have the board files different than the BOM files, you can do that. You can also interact with your AVL once you set it up. This is where you can change your internal part numbers to your external part numbers. If you want more information on how to run with AVLs, I'm not really going to go over it today, but if you want more information about that, just let me know and I'll do like a one-on-one and I'll show you also where the help file is for it. The help file is actually pretty good, so you probably won't need my help for it. And this is also where you interact with your parts library. So you can either transfer parts information from the part library into the part list or from the part list to the part library. And this is actually easier done than said, so it's actually harder to explain than it is to do. So once you have a project and you have a bunch of circuit cards inside of it, and the circuit card is made out of files, and you've done all the things you're going to do to your parts, it's time to run an analysis and view the results. That's basically everything in the drop-down menu related to project. This is a really good place if anyone has any questions. Excellent. So no questions, that's perfect. Now let's talk about the general Sherlock menu items. The first one is the tools. Obviously we have a unit conversion tool. There's a plated through hole fatigue tool, which basically calculates, actually calculates the number of cycles to failure for a specific plated through hole. We also have a solder fatigue tool, which will calculate the number of cycles to failure for a specific package that you choose with all of the specific information that you put into it. That is good for the kind of people that walk into your cubicle and ask you, hey, I just have a question. Can you give me a quick idea of whether this component will last or not? And it gives you really a rough idea based on kind of board properties, kind of temperature cycle, without going into too much detail. And then as soon as I close that tool, that information is gone. It's not saved anywhere. So you need to either do a screen capture or capture it in some other way. So that's kind of like our standalone calculators, but we also have managers. All of the inputs in Sherlock, you can control all of them. And when I click the Laminate Manager, this will pop up all of the laminates that I have inside of Sherlock. Right now, we've loaded up 400 data sheets. I don't trust anything that the data sheet says because they're really not very good at giving you real information, but we have 400 here, which is way too many laminates. If I was you, I would recommend to grab all of these laminates, delete them, and actually start with the laminates that you're actually using. If you want to keep these in here, this will kind of give you, if you're really in the early design phases and you still have the ability to maybe change laminates or look at other laminates or look at other properties, you can basically get an idea of what else is out there. And again, this is datasheet information, so it might not be the most perfect one, but if you look at any one of these, you can edit any of the materials that you want. You can right-click and export this directly as a CSV. So someone else can use it too. Sherlock is very agnostic about the type of information that we allow to flow in and out of our software. You can then later import these laminates if you wanted to. So you can actually create as many laminates or manage as many laminates as you want through an Excel sheet and then allow all of your Sherlock users to use them later together. So if you have a bunch of, most of the time you have 3, 4 Sherlock users in the beginning, and then most of our users, most of our customers end up having something like 14 or 15 users. When you get to that numbers, anything above 10, you kind of want a procedure, and you want everyone to using the same properties. So I would recommend when you get to that point, grab all the laminates that you are using, right-click, export laminates, and then tell everyone to go file, import laminates. So that's the laminate manager. We have the exact same thing for material manager. Since I talked a lot about the laminate manager, it's kind of exactly the same thing. All of the materials that we use in Sherlock, you can edit any information that you would like. you can actually, here, if you put in any information that you have here, right-click, again, export material, and you can export a bunch of materials. You can export all of them. You can add a material. You can copy a material. So you can start with the material, make a copy of it. You just need to give it a new name, and start kind of like with a known material that you kind of want to modify. So if you want to look at what happens if I change here, one of the good ones to look at is the QFN, overmold QFN. You'll see that they're all the same except for the expansion. So the CTE is 7, 8, 9, 10, 11, 12, because there's so many overmolds that are used in QFNs, so many different ones. We basically allow you to choose any one of them, but you can do this to any material that you would like. That's the materials. And then we have the package manager. The package manager is kind of cool if you're weak on packaging. It gives you a picture of what the package looks like. It gives you all of the information. So for example, if I'm looking at, here's a C-bend. If I look at a C-bend, if I double click on this guy, it'll open the C-bend component. Come on. And it will open a 3D model for me. And this is all parametrically created. So this was just created right now by the by Sherlock, just for the purposes of showing me what this thing looks like. So if I want to change anything, I can do a right-click and edit, and it will open up an editor, and it allows me to edit any one of these packages. So if I don't agree with this package, I can do that. I can also right-click and copy a package and create a new package. Let's say I want to look at the exact same package here. Let's grab a QFP. Here we go. So let's grab this QFP, and let's take a look at it and say, I want to look at what happens if I do custom lead forms where I'm going to change this lead geometry from 1 millimeter to 2 millimeter to 3 millimeter or something like that. And I want to see what happens to it. So I can copy paste this QFP as many times as I want, and for different packages. And again, this will only happen locally. You're not actually creating a package. And then if you would like to, you can also send someone a picture for your report that will have the model in it as well. So this is the model, and this is a PDF, so you can send someone this PDF, and anyone who has Adobe Reader, this is Adobe Reader right now. So anyone who has Adobe Reader will be able to see this, and you can send them, look, I did the 1 millimeter, 2 millimeter, 3 millimeter, which is kind of cool. So the regular export function, import function works here as well, and I'll show you kind of how we use it a little bit later. So that's a standalone tool. Let's talk a little bit about some settings. There are only 2 settings that I really want you to know about in Sherlock when you open it, and then we'll talk about the rest of them as you get like better and better at using it. So the first thing that I want you to see is I want you to see the license setting. So this is where you import your license. The first time you open Sherlock, you will see this, and it will tell you invalid license, blah, 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 blah. And then you will click import. You will grab the license that Tom will send you. You will import it in. You will click reconnect, and that will activate Sherlock. You only have to do this once ever. Another setting that you set up, FEA settings, you go here and you grab this little button. Whatever this number is, divide that by 2, and that's, I'm sorry, -2, and that's the number that you click here. So if you have 8 CPUs, use 6. If you have 4 CPUs, use 2. If you have 16 CPUs, use 14. And then the last setting is the launcher setting. And basically the max memory size, depending on how much memory you are using, how much memory you have installed, that's how I would set up my memory. But you can basically manage it however you want. Usually what I do for most people is I say, whatever this number is for installed RAM, divide that by 2. And if you have a question about this and like how to do this, just email me when you're actually in front of the machine, because you only have to do this once, and everyone forgets how to do this. So when you install this and your buddy in the company installs it again, you'd be like, oh, there's some setting, I don't remember where it is. Just let me know, and I will take care of you, because you only have to set this once ever. You do not have an admin tab, so let's not worry about that. And here's the help. Most of you have been in the industry for probably 20 years. you probably have been using electronics for a very long time and computers for a very long time. You usually think, our natural instinct is to think of the help menu as useless. I promise you, in Sherlock, the help menu is actually quite useful, and I'll show you a bunch of things here in the help menu that are useful. Help, show console, this is everything that has happened in Sherlock since the moment I opened it up. If you click clear here, it will delete everything. If you click copy to clipboard, you will then be able to grab it and Control V right into an email, notepad, whatever, and send this to me anytime Sherlock burps on you. Send it to me so that I know what's going on. This is kind of lets me know in the background what happened, and especially when there's an error. Okay? So you can click the clear, you can click the copy to clipboard. So that's the help show console. Help, task monitor. Sherlock has an internal task monitor that allows you to see kind of what we're doing. In a moment, when I start a project, you'll see that things pop up here, and we'll take a look at what happens in the task monitor. There's little question marks in a bunch of places that will tell you and explain to you what some of these things are if you want to. After the task monitor, there's the tutorials. Honestly, if you remember absolutely nothing from this entire thing, this entire webinar, you're kind of phased out completely in doing emails, please pay attention. I want you to remember help, tutorials, lesson 1 through 6. This is what I want you to do after this. The first thing you do is help, tutorials, lesson 1 through 6, and start with Sherlock here, and then afterwards open up your own project, and once you have your project, hit the user guides. Now, I would recommend for you to do all of the tutorials. The reason is they teach you where a bunch of the buttons are. So the tutorials are useful even if you're doing something in the tutorial that you would never do, like you're doing a harmonic vibe analysis and you would never do a harmonic vibe analysis. I would still do it in the tutorial just because it teaches you something about where the buttons are and where all the features are. But when you open up your own project afterwards, do the user guides that you think are interesting to you. Only the ones that you actually think will be useful to you. So if you're not using an AVL, don't worry about this. If you're not doing, you don't care about the laminate, don't worry about it. If you don't care about, I don't know, parts list management, don't worry about it. Okay, so all of these, just do the ones that you care about, read the ones that you think are interesting, and this is kind of like your reference guide for everything. Show console, help, part properties. When you click on this, it opens up a PDF. If you're weak on packaging, this will help you. If you're trying to build a library, this will help you. This has every single parameter that we use to describe a part. It has the actual code. So this is the actual variable name that we use inside of the software to define this specific parameter. So we give you the actual hard-coded and how to use it. And then we also give you the name of it. So this is the name, this is the variable name, and this is the description of it. Most of them have pictures, so if you're kind of weak on packaging, this is really, really good because it has a lot of pictures of what we mean by everything that we do. If there's anything missing, anything you'd like changed, I have complete control over this PDF. I usually keep it open at all times when I'm using Sherlock. And not only that, remember this is just a PDF. So you can export this and give it to anyone that you're interacting with and tell them, look, these are all the things that I can track inside of Sherlock. So, and these are the variable names, these are the names of it, this is the explanation of it. So actually, if you disseminate this to anyone that you talk to, even if they're weak on packaging and they're weak on terminology, this will teach you the terminology. It's kind of like a glossary of Sherlock terms and things that we track for parts. Very important. I usually it's always just permanently up in my computer whenever I turn on Sherlock. There's some release notes. So the release notes are kind of cool. What I like, so this is what I think about the release notes. They serve really two purposes. Number one, when you install a new Sherlock, you kind of read through this and you're like, oh, it updated this thing and that thing. Oh, there's a bug fix here. There's an installer here, blah, 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 blah. So if I see any bug fix and I happen to see that bug before or I happen to not notice that that bug exists, I can go back to a project that I had previously and be like, oh, that's why that didn't work, because of this bug, and now I figured it out. Okay, I should run it again because they fixed that bug. Another thing that this serves, so that's obviously nice to have information. Another thing that it serves is, it's kind of like marketing material for me right now, because I can show you that we actually put in a ton of work into our software all the time. So this just happened in the end of January, but I can show you that we go back. I have release notes going back to like Sherlock 3 that you can download off of our website. And if you can't find them, just let me know and I'll send them to you. And you'll see how much work and how much progress we've done with Sherlock over the last like 3 years, and you know we're just going to keep doing more. What's more important, most of this is customer-driven development, meaning that the customers ask us to put something in and we do it. That is an excellent thing. So if you're a customer right now, I promise you, if you ask me to do something, there's a high probability in version 5.2 or 6.0 or whatever it is, there's a high probability that it will end up in the release notes somewhere. So most of the stuff that I see here, I can remember which customer actually asked for this specific thing, and we were like, yes, that is a great thing. Like the L lead option, I know that there's a guy in Detroit that's very happy that we did this for him in the automotive industry. All right. So that's the release notes. The last thing I'm going to show you is the About Sherlock. This kind of tells you what Sherlock thinks it's installed on and which version you actually have. This is really good for people who manage a bunch of computers, or if you have a virtual machine that runs this, or if you're doing remote desktop to a desktop solver, or if you're doing this in any other configuration that isn't just like Sherlock is installed directly on your machine. This will verify it. There's also the end user license agreement that no one ever reads. Your legal department probably read it once and signed off on it, and that's done. All right, we're done with the drop-down menus. Now it's time to actually use them. This is also a really good place for questions. No questions yet?
Not seeing any, Gil.
Excellent. Thank you very much. At least I know Mark is awake. At least I have one person listening, right, Mark? So here we go. Let's do a
You always have a person listening in me, Gil.
Thank you, Mark. So here, let's do a project. I'm going to do the first one I'm going to do is the tutorial project. I'm going to do project import ODB archive, and I'm going to go to C, right here, program files x86, DFR solutions, Sherlock, tutorial, ODB++ tutorial.tgz. That's where it sits. So C, program files x86, DFR solutions, Sherlock, tutorial, ODB++ tutorial.tgz. Select directory or file, give it a name, training February, circuit card name, best board ever. Yeah. So Sherlock is telling you what to do now. Press the Scan Archive button after selecting the desired ODB++ archive. Okay, Scan Archive. If you don't know what PRP mapping is, don't worry about it. If you do know, this is where you do it. Click OK. Sherlock is telling you what's about to happen. The following import actions will be performed when you press the Import Archive button. It'll add a project called Training February. It'll add a circuit card called Best Board Ever. It'll add board properties, this, that, all the way down to drill holes. Risky click of the day, Import Archive. All right, so let's look at the task manager and let's see what happens here. Let me do some rearranging of the size of this thing. And let's do that. Okay, all right. So it loaded a bunch of things, it imported the ODB++ archive, and then it started parsing files. And Sherlock is telling me in the notes that this file was successfully parsed into a layer representing the data. Okay, a bunch of layers. There's a bunch of parts list items, so that's component top and component bottom.odb. So it parsed a bunch of things into parts list and more data. So let me show you what just happened. There's a project here. Let's actually look at it this way. There's a project here called Training February. You can see that I do a bunch of these trainings. Training February, and you'll see that this guy does not look like the rest of them. He has a little triangle, and he looks like an open folder, whereas these guys look like closed folders. Watch what I'm doing now. I'm going to click. A lot of clicking. I promise you, I'm clicking a lot. Nothing is happening. The only thing I can do with a closed project is a right-click, open project. and then it will open it and will create an open project. This does two things for me. Number one, I can't accidentally click on a project that's closed, so I can't accidentally be working here when I thought that I was working down here on this project. So I can't accidentally do things here. Number two, when I do this close project, it offloads it from the RAM, which means I have more RAM to actually run what I'm doing, the current project. I would recommend to you, have everything closed except for the project that you're actually working on right this minute. So everything should be closed, and the way to close it is right-click and close the project. Okay, excellent. Now that we have a project, let's take a look at it. So I can click on this little triangle, and it will show me the project tree. Before I go there, right-click on the project, project properties. Here I can do a description. So I know that most of you are used to the way where you save a file name and you need a big description in this file name, like, you know, board number 1, you know, version 3, not for publication, only this team, blah, 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 and it becomes a very long file name. Here I can put training board for new users. Mark is in attendance. Hello world. I can do anything that I want in here. I can put anything that I want in here and then save it. When I bring up the project properties, it'll bring it up again. So essentially, I can go to a project, open it, look at the properties, be like, oh, this is not the board that I meant to see, because you can write whole paragraphs here. You can write whole stories about what this project is supposed to do and what is supposed to be here. So this metadata gets saved in Sherlock and follows the project for as long as you have it, well, until you change the thing. So that's kind of the high level in the project. So right now I have one board in this project. So I have the life cycles, which are the loads, and I'll talk about them in a second. I have the results, which don't worry about that right now. We don't really have any results right now. And then I have the board. I have one board right now. If I had more boards, it would be like, you know, CCA2, CCA3, CCA4, CCA5. Underneath the life cycle, if you right-click and do a load lifecycle, I have a previously created lifecycle. This comes from like my field condition, my field engineer. Let's take a look at this lifecycle for a second. This board is supposed to survive. So this specific board is actually a water pump board. So this is like one of those big, huge sewage pumps that you see in like sewage or water movement, like water treatment plants, things like that. And they're used to having 30 years. And these things have like a 3% probability of failure in 30 years. And now you know that when you take electronics and you take it from and you put them inside of that application, so they didn't used to have electronics sitting on the pump. But you know that now when they're going to start putting electronics with like calibration and I/O and all kinds of things that happen to it, you know that they're not going to be getting a 30-year life out of it. A 3% probability in 30 years, it's probably going to be more like a 10-year life that they're looking for the board, not for the pump. All right, so we have various phases. Here's a shipping phase, shipping profile. In this case, it happens 3 days. Random vibe in various directions. Here it is. You can change any of these. I can edit it by simply moving it. I can edit it right here. And change the random vibe profile right here if I wanted to. And again, I can change it here and do a save as well. So I can do it graphically, or I can do it directly loaded from an Excel sheet. I have a temperature cycle here. Here, let's show you a little bit more of an interesting temperature cycle. I have a pumping temperature cycle. This is what happens to this board. The water in the treatment plant is at 100. It's at 10 degrees C, and as you turn on the pump, it gets hotter and hotter and hotter. It goes through some calibration the first, 5-10 minutes, and then once it's in operation, it gets hotter and hotter and hotter. It goes up to 65 degrees, and then it goes back down to 10 degrees. Excellent. I'll show you a little bit of things about that later. There's a harmonic vibe profile. Here you go. It has some high frequency vibration. I can change it again graphically if I wanted to. Some high frequency vibration here, and then a bunch of other things in the profile. And then I can have a shock event. This is my shock event that I'm I'm running here. This is a 10G load for this. It doesn't actually see this in the pump start, but I kind of made it artificially high in order to create failures during shock. But so you have a life cycle with your usage condition, usually comes from your field engineer, and the only thing you have to do is right-click, load life cycle. So everything I've done up till now, I've done in 2 clicks. One of them is to import the ODB archive. The second click is to load the life cycle. All right, so let's take a look at the board. The board is built out of 4 things. You have the files, which is kind of like the raw data. You have the inputs. The raw data gets processed into inputs. The inputs are the model. You run an analysis on the model, various analyses on the model, and then you view the results. Let's take a look at the files. Here are the files that I have. And again, it's kind of boring. There's really not much I can do. I can right-click on any file and do edit properties. Okay. You can write content here that you want, any comments that you would like. If you have a file, you can view the file, edit properties, delete the file. You can also view it as a layer if it's something that got processed into a layer. In this case, this is a copper, and here's a drill, view the layer. If I right-click on any one of these and I do view file, this is just a drill file from the ODB, or a component file here is a component file. That's just a parts list from the ODB. So you can actually look at the raw data. If you do a right-click here and do add files, I can add any file that I want here. Let's grab something off my desktop. Let's grab this guy. Let's also grab, let me see what else I have. Let's grab this guy. There you go. Grabbed a couple of files. You'll see that Sherlock automatically recognized this PDF. Okay, so it's just a data sheet of, a specific data sheet, great, of one of my parts. I can basically load all of the data sheets that I have for all of the parts on the board if I want to. I can load pictures of the board during operation. I can load pictures of the way it's mounted into the vibe table. I can load Outlook messages, whatever. I can also load files that Sherlock doesn't recognize. Take a look at this file. It's just a file. Double-click. It's just a PowerPoint. In this case, it happens to be some marketing material that we have here, but it's just a PowerPoint, so I can actually load test results, Excel sheets, whatever you want. Go crazy here, no problem. Load whatever you want into here. Sherlock will keep it for you. Even if it doesn't know what to do with it, it'll ignore it. If you think it's a file that should be processed, you can process any one of these files. Look at all these file types that we can process, and I'll show you how to do that a little bit later if we have time. All right, excellent. So the board has files, and then the files, which are the raw data, get processed into inputs. Remember that I said that the board is made out of 2 things. There's a board, the actual circuit card, and the parts. So the board, we take care of it right here. That's the stack up. If you take a look at the stack up here, let me show this again. So this is about 15% copper, and this is about 90-something% copper, right? So that's where the 15% and the 94.8% copper come in from. So this is your stack up. You can, if you take a look right now, Sherlock guessed that it's some generic FR4, kind of a worst case scenario. You'll see it's 17.4 parts per million per degree C in the board CTE. So, and it processed every single one. The way it got that, it processed every single one of the layers based on its copper content, and you'll see that 2 layers that have different amounts of copper will have different densities, CTEs, and so on. And then it takes all of the CTEs, all of the densities, all of the moduli, cooks them up, and puts them at the top here. So this is kind of a summary of the board that you're looking at, and this is more of the details for every single layer that you have. So you can actually see what you're getting from your board layout. You can change anything that you want. Double-click on any one of these allows you to edit. There you go. If you grab a bunch of them with a control-click, edit, no problem. You can grab them also with a shift-click. You want to do something different to the core. For example, you want a different core than you want the outside. Sure, whatever you want. There's a bunch more things here that you can do. There's also a button that selects all of the conductors together, selects all of the laminates together. All right. So now that we've done some things with the stack up, let's talk about the parts. I open the parts list. This is the parts list. Before we do the parts list, let me check the questions. No questions. Good, excellent. So let's take a look at what we see in the parts list. The parts list basically has all of the part numbers that came in from my board component bottom and component top.odb. The way I know that is because anything that's blue, everything's color coordinated. Everything's color coordinated, and you can look at the top what the color coordination does. So if you look, anything that's blue came from either the PCB or the pick and place file. Anything that is purple came from my package database. So here, let's take a look at this guy. So this guy, Sherlock guessed that it's a capacitor because it says cap over here and it says part properties. Sherlock is a pretty good guesser. I wouldn't trust it though. I always, verified before. Sherlock is a pretty good guesser. It misses sometimes. It grabs the part number and it tells you where it came from, component top.odb. It says, I don't know what the manufacturer is. Okay. Package database, let's see. Let's click this, package properties. Let's click this triple dot button. You see the button with the three dots in it. Originally, the pick and place file said that this is in component top.odb said that it's something called ADS SMC 1210. But Sherlock recognized that this is an SMT 1210 and said, hey, I recognize this in my package manager. So if you take a look and you look in the package manager, I know what a 1210 looks like. So I'll put in all the properties for that 1210. Excellent. But I know this guy. I've seen him before. We're Facebook friends. Parts, update parts list from part library. I'm telling Sherlock now, hey, Sherlock, look in my part library. See if any one of these friends, I've seen them before, and see if you know anything about them. So Sherlock went into the part library and downloaded all the information that it could find about it. So now you can see that the manufacturer is here, the capacitor is here. If you take a look at the package, originally, Sherlock said from the pick and place, this is ADS SMC 1210. The package database said that this is a 1210. The parts database confirmed that it's a 1210. So watch what happens as a manager. When I run through this, I can just go up and down and see everything is green. Awesome, meaning I found all of the parts that I have in the parts list or in my part library, and I found all of their properties. And if I take a look at any one of these guys and I say, oh, wait, one of these properties is wrong. One of these properties is like a guess, then you can start looking at your library and making your library better. So you know the origin of everything. Sherlock doesn't forget any of the information. It's still in there. It allows you to still interact with it. It just shows you the last one, and this is the one that's committed right now. But it remembers everything you did. There's a bunch of filters on the top here too. Show me only things that have a C. Show me only things that have a U. Show me U2. There you go. Show me things that only have an 0805 in the part. What was the other one? ECJ. Show me only ECJs. ECJs in the part number. Big J. So only ECJs. Only capacitors. Only certain types of packaging. Only the top and the bottom. So we have some filters here as well. So once I'm done with the parts list, once I updated all the parts information that I want in the parts list, I already did the stack up. It's time to go to the layers. This is the layer viewer. I'm looking for questions and still nothing popped up. Okay, so here's the layer viewer. Let me introduce you. Oh, finally, yes, thank you for a question. If I modify parts and do not update the layers and then change the project name, update layer option is deactivated. Did I miss it? Yes, you did. Yes, you did. If you mess around with the project name while you're doing things, you might have messed something up. Yes, is the answer to that. Shoot, I know, I'm sorry. Okay, so let me introduce the layer viewer to you for a second. So if you take a look here at the layer, it has 3 buttons at the top. The file button is kind of boring. It's just basically export an image. Okay, and I'll show you how you can do that. So for example, if you wanted to just show the components on the top and all of that, file, export image. Usually I just use print screen, but once in a while I want something for like marketing material. I want something to be really, really big, so you can actually scale it, and it looks so much better than a screen capture. So this one will look much, much better when you like zoom into it. Especially for large boards, you can do like a scale factor. I think that about like a scale factor of 10 is about as high as I usually go, but you can do this to whatever you want. There's also a view here, zoom in, zoom out, but I can kind of do that anyways by either scrolling up and down. I can use these two buttons here, and I can zoom fit by using this button over here. So kind of boring, but there's one in the middle, and this is where everything happens. This is where you do most of your interaction with the layer. This is where you edit a bunch of things. Before we start editing things, let me show you some stuff about the layer editor. The layer viewer in general, it's kind of like transparencies. You can turn on any layer that you want, and it will turn them all on. If you turn too many of them on, it becomes a little bit of a mess, and it's kind of hard to actually know what's going on. So let's not do that. Kind of only turn on the ones that you want for whatever it is that you're working on right now, and that usually will work well for you. There's a bunch of things, filters at the top that you can filter out. So even though the components is turned on here, I can turn off the components but keep the labels. See? Turn off the components but keep the labels of the components. Turn off the labels but keep the components, which is kind of cute. I use that once in a while. Visualization of leads. I can turn on and off the axes if I want to, these gray lines here. This is good for like marketing material visualization, you know, into reports and things like that. It'll delete those lines for you that show you where the 00 is. And they're not really useful for anything other than that. So that's that. These are where you turn on all the various layers. And then at the bottom here, you have a bunch of filters. You can filter out parts, show me only things that are bigger than 10. Show me only things that are bigger than 10 and have the label U. Don't forget to get rid of the label filter, because the worst thing to do is to close this, open this up again. Oh my God, heart attack, I don't know where my stuff is. Here, my label filter, and here is my part filter. Zero that out. There's also a package filter here. You can filter by specific packages, you can filter by part number, or you can filter by part type. So those filters work exactly as you'd think they would. So let's take a look at some of the editors. Edit, let's do, I'm going to do the first one just because it's the one in the top. Edit components. The edit components, any one of these editors in general, when you click on this, it'll gray out the rest of them. So which means that you're working on an editor right now, so you can only edit one thing at a time. And then at the bottom, it will open up these buttons here, and one of the action buttons will always be help, and the help will tell you all of the various things that you can do. So if you don't remember what I'm saying now, just remember the help button, right-click, rotate. If you need to rotate a part, this happens a lot in pick and place. Sometimes the rotations don't come out. So you can rotate things by one. Becomes a little bit annoying when I have to rotate a bunch of them, so I can do a control click, control click, control click. I'm actually just have the control down, and then just click on a bunch of them, which is really kind of annoying because if you know me, you know I'm a little bit lazy, and I'm going to do a shift, click, and drag, and that way I can grab all of them and rotate them together. So that's called the lazy button. So that's kind of how to rotate things. This happens a lot. Sometimes the length and the width are wrong, or sometimes the rotation comes in, you know, as 0 from the pick and place file without it actually being 0. Okay, let's take a look at the bottom of the board. Oh, in this case, I have to rotate all the R's, and I have to move these Q's to the correct location. This sometimes happens where the pick and place file will actually give you the location of pin 1, and everything's like rotated wrong around pin 1, so you'll see these wonky things once in a while. But what I wanted to show you here is how we do the label filter, how I use the label filter for effect. So I'm going to do a label filter. I'm down here. I'm going to do a label filter R. I'm going to press Enter. That way I can do a shift, click, and drag on everything on the R's and rotate 90. And then I can do a label filter for Q's, shift, click, and drag these guys. Then I can zoom into one of them. And then click, drag, and put it right here. There you go, and it moved all the rest of them. And I can do the same thing to these guys. These guys I'm going to do a little bit more of them. Eyeballing, not bad. Good enough for government work. Kill the label filter. There you go. All my parts are complete. You can move parts around as much as you want, and it will actually put it back into the parts list so you can then export the new locations for your ECAD people, and they can translate it. We made mistakes on this layout on purpose. There was a reason why we made this mistake, so that you'd have to go in here and change these things. highly likely that most of your ODBs will be better than this, so they won't have these mistakes. If they do, don't worry about it. Just correct them right here, and you can let your ECAD designers know that there was an issue. You can change the board outline. You can either draw an outline from scratch. Here you go. So four points make an outline, make a square. I don't need to close the outline. The last one will automatically close. Here, let's do a reset here. There's a help menu as well. You can actually edit an existing outline. So here, let's grab an existing outline. Shift, click, and drag will make new vertices. And I can make kind of any shape I want. Ooh. Happy Valentine's. And if I don't like these, any of these locations, if I don't like any of these vertices, I do a control click on a vertex, and this will kill the vertices. You will be doing this a lot, especially with boards that don't have sharp corners like this. Anything that's rounded off, usually it comes in from the ECAD as a bunch of points here, and you really don't need that many points. You can just kind of, create a straight line that goes through that point. But you can do anything you want with the board editor, and you can edit the board outline that way. So save on this. You can change mount points. Here we go. Let's turn off this guy, and let's just look at this. I'm going to turn the mount points off and on and off and on. So you can see that there's a bunch of black dots here. Again, there's a help file here, but if you take a look at any one of these dots, obviously we made some mistakes here. So if you, Sherlock will automatically take a look at the big holes and say that hole is a mount point, because we usually mount to big holes. Look, Sherlock made a mistake. It accidentally created these holes as actual mount points when, it's kind of obvious that they shouldn't be. These guys are just holes, not mount points. So you can grab them and, like I said, do one at a time. You can also control and delete them with the control button, delete mount points, or you can grab a bunch of them with a shift click and drag, right click, delete mount point. Oh no, I have deleted a mount point that I actually wanted, this guy. Right click, add mount point. It allows you to add either a mount hole that's center or outline constrained, center or outline constrained. You can make it as a rectangle, polygon, circle. The polygon is just the same as our other editor, the outline editor. You can make it into a mount hole, mount pad, which is 90% of the time I either make it into a mount hole or a mount pad. Usually I just make it into a mount pad. And then standoff allows rotation at the bottom, and then a support pin. This is kind of rare that I use it, but if you wanted this kind of condition, you can do a support pin as well. Excellent. So that's how you add a mount point. If you want to add a mount point, though, that is directly related to this point, to this drill hole, shift, click the drill hole, and you'll see that there's a mount point. It automatically creates it into a mount hole. Here, I can change it to a mount pad. I can change its diameter, but I cannot change its location. You see how it's grayed out? So which basically means these two are mated into a to one another. So this hole will always be associated with this mount point, or this mount point is always associated with this hole. Shift click the other one, and I create another mount point. Save. Excellent. There's a bunch of other things that I can add here. I can add heat sinks, cutouts. You can take a look at these all the way down to like modeling regions. Excellent. We also have a distance tool, which is very simple. You click this little triangle down here, shift, click, gives you a distance between 2 points. Excellent. So that's kind of like the layer. So what I've done is I grabbed a project, this project. I grabbed this board, which has its own properties as well, which I can do whatever I want here. I can write anything I want. I grab this board, and then I can grab a bunch of files. I process the files, which are the raw data, into inputs, and now it's time for me to run the model. Before I do that, I'm going to show you two things that don't really matter. If I double-click on the layers, here, let's turn on some layers, okay? If I double-click on the layer viewer, you'll see that it's kind of a mess, but it remembers the last configuration that I had it. Because I do this a lot, I asked for a shortcut to a pick and place file. When you click on pick and place, it only shows you the components. It basically clears the layer viewer of anything but the components, top and bottom. And when I do drill holes, it does the same thing, just shows me only the drill holes. These are kind of shortcuts. That's the only reason they're here. That's all they do. Double click on the net list. We don't do anything with it. We don't manage the net list. All we do is we read it, and from here you can export the net list directly, which gives you the X and Y location of every net, of every pin, and which net it sits on. If you double click on any one of these, it'll take you to shortcut to the part properties. You can't edit. You can edit the part from right in here. This is more for like the electrical people than anything else. So don't worry. Don't worry about this too much if you're not worried about net list. All right. So I processed all of this. Mostly I work on the parts list and the stack up because that's the boards and the parts. I did what I did in the layers to do some placement, to do a little bit of editing. Now I'm ready to run an analysis. Every single analysis runs exactly the same. No questions yet. Good. Every single analysis runs exactly the same. Right click, edit properties. You put in whatever the properties are. So all the analyses have different properties depending on what analysis you're running. And then you click save and run. Here's another one. Edit properties. I'm going to choose, the various. Here, let's do this a big mesh. I want this to run fast. Part modeling. Let's do minimum part size 10. So there's a bunch of properties here that I can mess with. And let's disable all of these guys. They don't matter. And I'm going to do save and run. Same thing for mechanical shock. I'm going to just do this guy, save and run. Natural frequency analysis. Plated through-hole fatigue. Pumping temperature cycle. Excellent solder fatigue. Save and run. Thermal derating. Save and run. Okay, so all of them is right-click, edit properties, save and run. And then it will run the analyses, and it will give you the results for all the analysis. Let's take a look at just one of the results here. This is a plated through-hole fatigue. This is a plated through-hole fatigue result. And let me introduce the results to you. So first of all, you get a scorecard. This is everything that you ran in the scorecard. It gives you a module score for every module that you run. Based on each analysis. The scores are based on best practices in the industry. Ooh, I have a question. Yay. Yes, you do need to change the individual analysis properties. So the question was, do we really need to change the individual analysis properties? So when you do a right click here and do edit properties, you do really need to change the properties here. The modeling properties kind of remain the same. You can keep them the same between all of the models that you run, the mechanical models that you run. But yes, the answer is you do need to run every time you need to do a right click, edit properties, make sure that you have the correct properties in here, save and run every single time. Yes, the answer is yes to that one. Sorry, let me get back to the results for a second. So the overall scorecard gives you the scorecard for all of the analyses that you ran. The life prediction curve gives you the combined life prediction curve for all of the analyses that you run. So this one is solder fatigue. You see the color coordination here. Plated through-hole fatigue. Harmonic vibe didn't really do. Mechanical shock didn't really do much. Harmonic vibe didn't really do much. Sorry, this popped up. And then it'll give you the individual results. So harmonic vibe, as you can see, life prediction, ooh, really, really bad. These two are failing. So you can see the life prediction is like basically it's going to fail really, really quickly. And what you were looking at is these two ICs, they have a very high probability of failure. They're the two big guys in the middle. So it kind of makes sense that they will fail relatively quickly. We'll take care of that in a second. CAF analysis as well. In the individual results, you'll see there's a summary. This is the picture for directors, okay? Colors, look, ooh, green, red bad. A bunch of numbers here that show you what I ran, So all of the analysis properties are saved here. This gives you a life prediction curve, an overall life prediction curve of the performance for the whole thing. This is the engineer's slide. This is what gives you the actual results for that the engineer is actually cares about. And this gives you any kind of warnings or issues that you have. And all of them have it. You see there's a score, there's a table, mechanical shock, life prediction curve, and life prediction table. Natural frequency analysis gives you an overview of all the natural frequency, plated through hole, life prediction curve, time to failure data, table. You can always export any table that you have here directly to Excel. Here, let's take a look at the solder fatigue. Gives you a summary of the solder fatigue, gives you a life prediction curve, which you can see that this is a 2.5-year board. Let's take a look at this table. It'll give you an individual life prediction for a specific component. You can also grab a bunch of components with the shift click, right click, view life prediction. So there's a bunch of things that you can do here. Excellent, and there's a lot of information here. Don't worry if you didn't get all of it. What does SCORE say about the analysis research, the results, how to interpret that? That is an excellent question that I will answer in a few minutes. All right, so we have a bunch of analyses that I ran. Here, let's run this one as well, just for giggles. So I have a bunch of analyses that I ran, and I have an overall life prediction curve for this entire board. Okay, so here's my scorecard. You know, obviously this board is going to fail. The tutorial board is supposed to fail because, you know, that's kind of how we do what we do. Because you're supposed to solve all of these problems. You're like a detective that solves all these problems. So I ran a bunch of analyses. I'm going to wait for this guy to run, which will take it another probably 30 seconds. And then I will generate a report and save the results. So that's essentially how I run through an analysis, is where I will grab the loads, I will have the board, I will do whatever I do to the board's parts and the board itself. I will run a bunch of analyses here, and I will view the results of the analyses, and then I will right-click here. I will lie to my boss and tell him, hey, look, boss, no, I'm really, really working very, very hard, and you know, it's going to take me hours to put all of these wonderful things into a report. You know, all of these, I need to take this, the score here, and I need to take, look, I need to take this guy here. You know, this is the stress results, and here's the strain results, and here's the stress, the displacement plot for random vibe, and here's the strain plots for random vibe. All of these things, I need to make them into a report, and here's the, you know, the displacement plot for my harmonic vibe, which I think harmonic vibe is killing my board, and here it is. And look, it has a, hold on, it's too fast. So it has a displacement here. Here's the displacement of the board, and you can see that mount pad that we did at the bottom. And here's the strain on the board, and here are all the component scores for the board. Okay, so you can see these two are failing, and it has this, and I can actually take a picture of it and put it here, and look, I can do all of these wonderful things in Sherlock really quickly. In order to do this, usually this takes you like 3 or 4 hours to create this report. In this case, you get this report automatically. Here's the overall life prediction curve. Here are all the parts that are failing in the various analyses. This is a summary of all of the analyses I ran, and then it goes into specific ones. Here's the circuit card design. Here's the my board properties. Here's my detailed results for, here it is, first natural frequency, second natural frequency, harmonic vibe, displacement, strain, results, top and bottom, and so on and so forth, and so on and so forth for all of these guys down to the solder fatigue at the bottom. So this includes plated through hole fatigue and everything. So this gives you all of the results for the entire board. Great. Fantastic. But I have a problem. This right now is a 2.5-year board. I can't deal with a 2.5-year board. Okay? I need something better. So I need to fix all these problems. So let's save this result and just remember it for later. Okay? So I save these results and I'm going to remember them for later. All right, first things first. My natural frequency, my first natural frequency is way too low. If you take a look at the natural frequency, and you do view layers, you'll see that the first natural frequency is smack here in the middle. All right, what do I do with the, how do I solve this problem? I will go here to edit mount point. I will grab this mount point that I already know how to do, and I will copy it, and I will put it smack here in the middle. Okay, so here, take a look. See, it's right here, and let's put it smack in. Well, actually, let's put it offset. So you can't tell me that I made this on purpose. Let's do that. Let's say AFA results. So that's the second natural frequency as well. Let's copy this mount point, and let's grab him right here, not too close to these components. Let's put him right. You know what? Let's do something else with this guy. In properties, let's make him into a rectangle. And let's do this right here along the edge, okay? Along the lip. So he's right here. Great. That should solve my natural frequency related problems. While I am doing that, let me do edit properties. Oh, hold on. So I have one more problem that I need to solve. I still need to solve the solder fatigue issue. This guy right here. Let me show you. So I'm going to go into my stack up, and I'm going to say, all right, we got to do something. So it's either the parts or the board. I can't really change the parts, so let's change the board. Let's go to my Laminate Manager and grab a really good, a really expensive, really good board, 370HR. Watch what happens when I do this. From 17.4, 13.4. Let's see what happens when I do solder fatigue again. Edit properties, save and run. And I'm going to do plated through-hole fatigue again as well. Edit properties, save and run. And I'm going to run my harmonic vibe. So let's run natural frequency first, just to see what happens. All right, so from solder fatigue perspective, I just made a 2.5-year board into a 4.5-year board. I still have to solve this issue. And I think we still have time to solve this issue. From natural frequency perspective, oh, hold on. Aha. So let's see the natural frequency. So I want to get that natural frequency higher. Let's see how long this takes to run. Hopefully, this should run in like 30 seconds, and that would be okay for me. And so I still need to solve this solder fatigue issue. Let me take a look at the plated through-hole fatigue. Okay, so this plated through-hole fatigue is fine. So if I get the new laminate, I'm okay. How do I solve this solder fatigue issue? Well, there's a way of doing it. So you remember how I did this? I told you about the pumping temperature cycle. It looked like this, and it went from 10 to 65. I'll tell you why that happens. Because I went and I did a analysis. I went to my thermal engineers, and I said, all right, give me an analysis of how much power is going into this board. And my thermal engineers did a really good job with the data that they had. Thermal maps. I'll show you what happened. I did a thermal analysis, and they said, look, this guy really pulls a lot of power, gets up to 82. I know that there's a thermal shutoff on the board that goes to maximum of 65. So at 65, the board shuts off anyways. So they said, look, everything gets real hot. And I said, all right, you know what? Most of the board goes to about 65. Cool. That's why I got the 65 from. But I built the board, and then I turned it on. And this is what I saw. I actually saw that the board doesn't actually get that hot. And actually, this component doesn't really do most of the work. This is the calibration component that kind of turns on in the beginning. It does a little bit of work in the beginning, and then these two are the ones that really do the calibration, constantly on the whole time, but they don't pull that much power. The maximum rated power of this guy is like 30 watts. It doesn't pull anything close to that. The analysis was done on the basis of 30 watts, but it doesn't even get close to that. So what I'm going to do is I'm going to say this guy is a thermal map. And he goes from 30 to 47, and this is what happens when I'm pumping. And watch what happens here. It allows me to map the board right here. Allows me to map the board to the picture, or the picture to the board. That's kind of close enough. And then grab the colors, so it knows what colors to go to. Done, save. Watch what happens. Boom. Component. Awesome, right? Look at that. So basically, this component, instead of going from 10 to 65 everything, look at the number up here. I'm looking at the number up here, okay? Above the 3, you'll see something pop up. Oh, you see that? So this component will go from 10 to 36. This one will go from 10 to 38. This one will go from 10 to 42, and so on and so forth for every single component and everything single plated through hole on the board. Not bad for a 15-second amount of work. All right, so now let's run solder fatigue again. Let's run plated through hole fatigue again. And let's run natural frequency. All right, so let's take a look at solder fatigue. So in solder fatigue, just about close enough and might be able to be okay at this point. Okay, definitely you can see that each component gets a different delta T. They all turn out green. It's just under, so at 10 years, it's just under the 3%. Still a little too close for comfort, but it's better than the 2.5 year board that we had about 10 minutes ago. So just by adding the correct temperature profile and by changing a different laminate, I can show the board, or I can go to whoever is the decision maker, the project manager, so look, you can meet your reliability goals. You can do this as long as you do a couple of things, and you can put money down into it. You can also show this with money. So now that I ran, and let's take a look at plated through hole fatigue. Obviously, no issue there. All is well. That last problem we had to solve with the harmonic vibe problem. So here, let me run the harmonic vibe real quick, and let me show you what I did with the natural frequencies. So I created a bunch of mount points. I added some mount points to the board, 3 of them in the middle, and you'll see them right here. Okay, so I added these 3 mount points. So now, where my natural frequency was in the 100 and something, now it's in the 620 region. So 600 and something, instead of 180 something. So that's much, much better. Usually the higher the natural frequency, the better my response is going to be. Let's see, the first natural, this is the first natural frequency, this is the second natural frequency. So obviously I moved it away from these 2. They were the ones that were failing in harmonic vibe anyways. So when the harmonic vibe analysis finishes in a few seconds, I expect to see, here, and let's run all of these guys again, just for the giggles. I expect to see much better results this time for my analysis. And remember, the 2 ones that I had a problem with here, and I'll pop this guy up so we have something to look at. The 2 that I had a problem with were the solder fatigue, plated through hole fatigue, and harmonic vibe, if I'm not mistaken. Here, let's take a look. So this is my results viewer. This is a standalone viewer, which, by the way, you don't need a license to view this. Oh, I got one more question. What did you change other than changing the laminate to get better solder fatigue results? Okay, so I did the temperature profile. Remember that originally my temperature profile, so the question was, how did I fix the solder fatigue results? So my original temperature profile goes from 10 to 65, but I added the thermal image, which now allows each component to go from 10 to 47 maximum, right? So some of them will go down to only up to 37, and some of them will go all the way up to 47 degrees. So the temperature cycle, the delta T, is also smaller, and you can see it reflected in the solder fatigue. When you look at the table, you'll see that the max delta T is different for each component, and they're definitely lower, because instead of being 55 degrees, 10 to 65, they are now, some of them are in the 30s, 35, and so on. So definitely solve that problem. And when we look at the harmonic vibe now, look, no problem is in the harmonic vibe. You remember those 2 that were red at the top? Actually, you don't have to remember. Here, let's do this guy. Watch magic. There it is. All right, so side by side, my life prediction curve now. looks like this. So now I've definitely solved all of these problems, except for, solder fatigue. I'm kind of like shaving the edge of that solder fatigue. Okay. And I can take a look at harmonic vibe, and you'll see that in the harmonic vibe table, see those two BGAs were the worst ones, and now they're definitely not even a problem because I added some mount points. And again, quickly show people that it is worthwhile as a, this is an actual reliability assessment here that you can do very, very quickly. And if you take a look at solder fatigue, definitely a lot less failures here. But if you look, actually, most of my problems come from these V-chip capacitors. The V-chip caps are giving me everything. So if you take a look here, let's do this. So I'm going to grab the V-chips. So this is so let's forget about the archived results. Let's just look at these guys. So this is my V-chip capacitor probability of failure, only these guys. Now I'm going to take everything else with a shift click and do a view life prediction curve. So if you take a look, the V-chip caps have almost a 0.5% probability of failure. They contribute more than almost all the other parts together. So all the other parts together have a 2% probability of failure. The V-chips alone have 0.5%. That's a huge difference. So if I can get rid of these V-chips, if I can get rid of the capacitors here, these guys, if I can get rid of these guys, I can go much, much lower. So I can go from, what was the total probability of failure? Here we go. So I can go from 2.5 to 2 just by getting rid of those 5 components. This is worth it. This is worth it. Okay? So anyways, now I ran this again and I can redo the report. There you go. And I can show those two reports side by side, and that is kind of like how I run a project. And you've seen a bunch of things that I did today. Let me, before I kind of send you off, let me give you a little bit of a summary. Oh, I owe you one thing. Hold on. Before I do the summary, I owe you one thing. I owe you what is the score, right? Like, how do you calculate score? So this is my new report, by the way, and I can take that PDF and do side-by-side comparison and give it to, whoever it is, the decision maker. In order to answer what the score is, I go to the project level results, right-click, generate report. This is a smaller report. If you have many, many boards, this one is worthwhile running. This report will show you the summary of all of the analyses. It'll give you an introduction to what is Sherlock. It'll explain how we do plated through-hole fatigue, calf, solder joint, and so on and so forth. It'll explain to you how to read a life prediction curve, in case you didn't know. It'll explain to you what the score is. The project scorecard is a scoring system that benchmarks the design of the project to best practices within the electronics industry. So that's the answer for what the score is. But it'll give you this is a full explanation of the score. It gives you the life prediction results, and it gives you the various loads that we had. Here's the random vibration. Here's the one that I changed. Here's the temperature cycling. Here is the harmonic vibe that I changed. Here is, a bunch of the shock loads and all of these things. So that's kind of the project level report. You can see that it has a lot less information, but it still gives you the essentials of everything that you would need in order to understand what goes on. All right. So now that we've taken a look at everything, let me tell you what we did. So I gave you a survey of of Sherlock. I gave you how to install Sherlock, which you probably forgot. It's okay. Tom will send you instructions in the email that he'll send you the license with. And if you run into any issues, you can just contact me directly by email or by phone. My email's on the website, and if you go to dfrsolutions.com, actually it's a really good thing to show you. So if you go to dfrsolutions.com, there's a phone number at the top right here. Call this and ask for Gil. And if you go to About Us somewhere, about DFR Solutions. If you go to DFR Solutions team, I am somewhere in here. I'm not in the executive team. I'm in the senior technical team. Somewhere in here, there's my name with my email as well, and you can email me directly. And then if you go to our resources, there are a lot of resources in here. We have a ton of explanations on how to do moduling and simulations, how we do our FEA, temp derating, what is physics of failure, all kinds of links to webinars. Honestly, I tell people that if they hire a new engineer and they came from undergrad and they're not really a reliability engineer, because we don't really have good undergrads for a reliability engineer, I tell them start up here, finish down here, click around on all of these things, and you will become a reliability engineer you'll at least know the lingo for reliability engineering in electronics by the end of this. And this is also where you can register for our Design for Reliability conference, which all of you should, and you should come over. It's in Baltimore in March. So that's that. So I went over how to install Sherlock. I went over the project menus and then the general settings for Sherlock, and then we did a project. We ran it once and we saw that there's a few problems. We solved some of the problems by getting a different laminate, improving some mount points, adding a temperature map. I know that this looks like a lot. It is the tip of the iceberg of what Sherlock can do. I promise you, there's a lot more in here that I didn't even start talking about. We have an intermediate and advanced training that happens once a year, or according to, if you guys want it, which we can do it on site. But this training will be offered again in a month, and the recording of this will be made available to you, which you can show to anyone that is a new user in your company. And all of our training, this webinar will be done again in a month. So sometime in March there's going to be another one, and then in April there will be another one. So we do this every month. And like I said, the recording is available to you as well. So if you want to onboard new users, you can do that as well. And if you have any other questions or anything like that, you can just contact me directly. You don't need to go through customer service. You don't need, there's nothing like that. All you need to do is basically email me, and I'll just take care of you of whatever you need, okay? And like I said, the recording of this webinar will be available to you. You just need to email Tom. Once he emails you the license, just email Tom. Excellent. Thank you very much. Mark, you are showing your screen.
I am indeed. So I just wanted to show everybody on the webinar this screen, and I see we have a question as well about getting a recording of the webinar. So the best way to do that is just look at the highlighted portion of my screen and email me directly. For all of those on the line who are looking to acquire a Sherlock license, Tom O'Connor is going to be the best person to go to, so email him directly whenever you are ready to receive the copy of your license. It's likely he'll be sending out a copy to all of you today, but if you want to get it or later today or at some point later this week, but if you want to get the copy sooner than that, you can do so by emailing him directly immediately. So I want to just kind of leave those two emails up as we close out the webinar here. I don't think we have any more questions other than that. I would encourage you to, looks like we do have a question. Okay. So I'm going to wait for Gil to get back to his computer, and then we will address that question for you.
Hold on. What is the next question? Can get a recorded copy of this webinar. That's the only one that I have.
I'm seeing one here. I'm actually seeing quite a few.
Yeah, but I answered most of them in the webinar.
You answered most of them? Okay. Okay.
Yeah.
Cool. So Yeah, so just email me for a copy of today's webinar, email Tom for a copy of the license. It looks like we're all through on the questions, and as Gil said, please definitely take a look at our Design for Reliability conference, which is going to be happening on March 20th at the Sheraton in Baltimore. So please go to our website for more information on that and to sign up. We'd really like to see you there if you can make it. And with that, I'm going to go ahead and close out the webinar, and have a great day, everybody.